Opal is hydrated, amorphous silicon dioxide spheres. The spheres are 300 to 500 nanometers, which is 1/1000th of a meter in diameter. They form closely packed grids, and those grids reflect light and create color. The larger spheres reflect the larger wavelength of light, which is red. The smaller spheres reflect the smaller wavelengths of light, which is blue and purple. Then how do you get the patterns in opal? The different varied little sparkles that you have, pinpoints, and then you have big floral patterns and big sheets of fire. How do you get that? You get that because opal has secondary crystallization. The opal silica gel flows into, in the form of, streams underground, in the form of seepages after a volcanic eruption, that type of thing. It forms into voids. It can form into voids of bone. It can eat away bone. It can have where it forms shells, and part of the chemicals that are in these form the structure that gives the different patterns of opal. A good analogy would be a famous French artist walking through the streets of Paris early in the morning noticed that the frost that forms on a florist's window was very floral and very sensuous, okay? And then he also noticed that when he went to a butcher shop that the frost that formed on that window was very blocky. Now this is kind of a rough analogy that you have different crystals of halite, you have crystals of orthoclase, calcite, you have all different secondary minerals that the opal replaces, and in replacing that it acts as little beds for it and acts as basically a format for the opal to form into. So sometimes you'll get big sheets of opal, sometimes you'll get little pinpoints, and you can have both sheets and pinpoints in the same grouping of opal. Other things that form aspects of opal are you get secondary calcites, orthoclases, and oxides, and you get different kind of minerals that are also in the opal that give it a body color. So I'm going to show you a little bit of opal here. Right here, these opals right here are from Virgin Valley, Nevada. Virgin Valley, Nevada opal is notoriously not stable, meaning that it has too much water in the structure. Now, and another analogy of that is when you go to a mud flat, right after the rains have happened, you have nice smooth mud. Let's consider that a nice smooth opal that's just been cut. What happens as the mud flat dries out, we see cat clawing or crazing, and that's the same thing that can happen to an opal. Some people say that an opal will craze if it dries out too fast, if it's taken out of its environment too fast. That's somewhat true. But opals can craze after they're cut, and there are certain fields of opal that are known to be very cracky, or that will craze. They're very unstable. Here's a large stabilized piece of Virgin Valley opal that came out of a large, probably a limb cast. A lot of the Virgin Valley opal out of Virgin Valley, Nevada are replacements of different kind of vegetation, different kinds of limbs of trees and other plants that have decomposed, and the water has seeped in and then solidified and become opal. Another grouping of opal right here, these are Brazilian opals right here. Now these are particularly interesting Brazilian opals in that this was a group of Brazilian opal that was hydrophane, meaning without water. When it was found, it looked like white chalk, but when they soaked it in water, it had a whole bunch of color to it. It didn't craze though, it just went from looking like white chalk to having fire in it. So a gentleman named John Slocum, who's local here to Rochester, he invented a process to embed the opal with plastic polymer and color. And these are some of the few stones that are left from his collection. So these are some embedded opal, and these are some non-embedded opal. Now, Brazilian opal does come completely stable, and here's a large Brazilian opal necklace in very stable Brazilian opal. So within one field you can have stable and unstable opal. So I'm going to put this back over here. I'm going to go over to Australian opal now. Now here's a couple of pieces of Australian opal rough. Here's a large chunk of Australian opal rough right here that you can actually see some crazed patterns on the outside. Now why does that have crazing in it? It has crazing because the field it came out of was not stable. Also it's a gigantic stone, and sometimes the larger a stone is, the less stable it will be. Now these are different samples. These are in sandstone. You can see it's kind of a sandstone matrix. Then you see where you have the fire right here. Here's an opal that's rough that I've gone ahead and I've planed it off. And this has some secondary oxidization below there that gives it that body color. And that black enhances the color of the opal. This right here is a cephalopod out of a squid. So this is a fossil of a squid, part of a squid, that actually became opalized. You find a lot of opalized shells in Australia too. And then here is a beautiful cut opal. But again, this opal right here has great fire and a beautiful kind of what we call patchwork pattern. But this opal has crazing in it. It's not a stable opal.